Okay, what we're looking at now is being able to find a specific term or the specific number of terms that it takes for a sequence to be either less than a particular value of epsilon or greater than a particular value of kappa. So we're going to look at a couple of examples in that. Okay, so our first example we have here is we want to find the least positive integer n, capital N, such that the absolute difference between 2n plus 7 over n plus 3 minus 2 is less than 0.0156, provided the number of terms is greater than that value n. Okay, so you'll notice we've got a value for epsilon of 0.0156, and we need to find the smallest whole number for capital N that makes that inequality true. Now, the absolute value of 2n plus 7 over n plus 3 minus 2 is less than 0.0156 if, so we go through the same procedure here as we have previously when we've been proving. We just happen to have a value of epsilon. Now that's true. Okay, we need to combine our fractions here. If 2n plus 7 minus 2 outside of n plus 3 over n plus 3 is less than 0.0156. If the absolute value of 2n plus 7 minus 2n minus 6 over n plus 3 is less than 0.0156. If now the two n's cancel and we're left with 7 minus 6, which is 1, so it's the absolute value of 1 over n plus 3 is less than 0.0156. If we can remove our absolute value symbols, 1 over n plus 3 is less than 0.0156. If taking reciprocals, n plus 3 is greater than now 1 over 0.0156. If n is greater than 1 over 0.0156 minus 3, if n is greater than, now that approximates to 61.1026 to 4 decimal places. We're after a whole number, okay? If the number of terms is greater than 61. It doesn't make sense for the number of terms to be 61.1. Okay, so if n is greater than 61, the number of terms. Now, what is our least positive integer, capital N? Okay, as it says here at the top, what is our least positive integer, capital N? Now, if the number of terms is greater than n, then that means that the least positive integer, capital N, must be equal to 61, because we're told here that the number of terms is greater than 61, and our statement at the beginning, that's what we require, n must be greater than n, so the smallest number of terms, n, must be greater than 61. So capital N, this is where it can be a little confusing, okay? Because little n must be greater than 61, the next term would be 62. But the number of terms must be greater than our value of n, okay? So that means that the value of n, capital N, must be equal to 61.